Okay, see Lindelof videos. Solve for exact values of trig functions. We're going to use intervals right now. This is the second video I've done on this today. So go back and look at the other one for a little bit of clarification on the finer details. But this is just an opportunity to do a second example. So what we want to know is when is cosine cubed x equal to cosine of x? So normally if we do that, we would get some weird answer that kind of repeated itself, because if you look at the cosine function, it kind of does this, doesn't it? Up and down, up and down. So it passes through particular heights. I said particular, certain heights, an infinite number of times. So we get these really weird answers back. And here's just an example of it. So I asked the calculator to solve 4 cosine x squared minus 3 equals 0. I want to know when that happens in terms of x. So I hit enter and it gives me all this crap back. And this is kind of what our professors and our teachers are kind of a trick they play on us, because we get this answer back and we're like, how the hell do I know? And they're like, well, exactly when. So there's a way. And the way would look like this. Remember, we're going to solve on an interval x is greater than 0 and less than 2 pi. So first thing I'm going to do, obviously, is go to the solve function. If you remember, it's this key right here. It's an alphabetic list of things you can use here, right? But I use solve so often mine's just set on solve, so when I open it, it's already on solve. So solve, and you remember I wanted cosine cubed theta. There is a really weird caveat with this particular calculator, and let me just show it to you first. So I'm going to use the trig function cosine. I'm going to use x is my variable. So normally what we would do is we'd have cosine and we'd have put the squared right here, wouldn't we? This calculator doesn't let you do that. It doesn't understand that. And if you try to do that, you just keep getting these syntax errors back, and it'll drive you nuts. It certainly has driven me nuts many times. But if you think about it, cosine squared x does mean cosine x times cosine x. So right now we're in the argument for x, so I have to get out of that argument, right? And now I'm still inside. If I put it here, I'm squaring the x, so I have to go all the way out. Now I'm squaring this whole cosine, right? This parenthesis and this one I'm on the outside of match, right there, the pair. So now what I'm going to do is I'm going to square this. This the calculator can recognize, except for the fact that I didn't want it to be squared, right? I wanted it to be cubed. So it's cubed, right? Remember, now we're in the exponent, so I'm going to use my right cursor right here in red to bring it down. I'm going to hit the equal sign. You kind of have to be careful of that kind of crap too. And sometimes you'll be in such a hurry and you'll look up and you're like, shit, my equal sign is up here by the 3. Not a good thing, right? So being careful. And then I'm just going to type in the other condition that I want is just cosine x, isn't it? So cosine x. And I want to know, when are these two things equal to one another? So this is still solve notation that I'm using right this second, right? So I'm going to put a comma here, right? So I'm going to put a comma here, and then I'm going to put an x. So in this comma in this x means in terms of x. So right now, if I press the button, I'll get this crap that I had before, right? I'm going to get this junk. But I don't want that. I want specific answers. So here is this crucial point, and I hope you're listening carefully. If you're taking notes, if you're screwing with this on your calculator, this is what's going to get you. This is what's going to screw you up. You see where my cursor is right now? It's still inside the solve argument, right? These big outside prints are the solve argument. I have to get on the outside of that before I can use this little trick that I have. So I'm on the outside of the solve argument, and now I'm going to go to control in the equal sign. You see these little notations over it right here. This notation right here is the such that notation. So now I'm saying solve this inside equation, solve this junk in here, such that, and now I can set my condition such that 0 is less than or equal to x, and x, back to this again, and x is less than or equal to 2 pi. Usually I use the pi key right here, but some people, and they just won't get off my whatever, so they want to see me do it this way. So to prove this works, do this. This works. It's 2 pi. It's the same as typing in the symbol. Now if I press enter and I get back a really good answer, I'm going to be so impressed. Bang. Wow. You see, look at this for a second. Just a quick comparison because we have a second. See this crap right here? This is what you don't get. This bold stuff is what's telling you that this thing's doing this over and over and over. This thing right here tells you, hey, look, bro, I'm only looking at this from here to here on this short interval. So you get back these exact answers. So this is actually pretty cool, I think. If you have any questions or comments about this stuff, please let me know. If you haven't already subscribed, will you please subscribe? And if you have interesting things that you want to see on this calculator in particular, I really encourage you to let me know. I'm dying to do these videos. I think I've done 300 videos on this calculator, so if I'm missing something, bro, let me know. All right. Hey, thanks for watching. I appreciate it.